In this video, we're going to talk about controlling microbial growth. In our previous videos, we talked about those environmental factors and the nutrients needed to encourage microbial growth and provide them the optimal environment, if you will. However, since not all microbes are beneficial and there are some that are pathogenic and cause diseases, we do need to learn how to control their growth to help prevent the spread of diseases. And as we look at different agents, one of the main goals for controlling microbial growth for each agent is to be able to somehow terminate a vital process in that microbe so that the microbe is no longer able to replicate or reproduce. And as we move through the different agents, you'll notice that time, the pH, concentrations, there'll be different factors that will impact how effective that microbe is. Now, talking about effectiveness, let's talk about the levels of control, how effective the various products are. There are going to be 5 terms that we can use. This is going to be applicable for this video and others. So let's first start with the highest level of control, and that is referred to as sterilization. When we say an agent is a sterilizing agent, then that means that that process, that agent, whatever we're using, has the ability to destroy or remove all vital microbes. That's going to include, when we say all, when we say 100%, that's going to include endospores, which are extremely hard to kill, and it's going to deactivate viruses. So sterilization, that's the gold star, if you will, 100% of death of the microbes. More things tend to be disinfectants, and they can be a high level of disinfectant, but when we say it's a disinfectant, it's going to either be a physical process or it might be a chemical agent, which is going to destroy those vegetative or living state of a pathogen. In addition, some of our various microbes produce toxin byproducts, and so disinfectants are going to be able to denature the proteins in those and to actually destroy or remove the toxins and prevent those from having negative effects as well. However, disinfectants, as good as they may be, are not able to destroy bacterial endospores. So only sterilization processes can do that. Antiseptic is a term that we use for any agent that's chemical in nature that is able to be used on living tissue, such as your skin or your mucous membranes. It's an antiseptic, and it can be used on the living tissue to destroy or inhibit those living pathogens in their vegetative state. Sanitation just refers to methods which are used to lower or reduce the number of microbes. They don't really do anything to inhibit processes or kill them. And contamination is just a term that we use for meaning mechanical processes which are going to physically remove microbes from a surface. So, when we talk about microbial control methods, there's going to be 2 main classes that we're going to look at: physical control and chemical control. This video, we're going to hit the highlights on the physical control. The second video is going to be looking at the chemical control. The reason, again, that we are looking at microbial control methods is because we want to be able to help with preventing the spread of microbes, preventing diseases. We need for food preservation, and there are some industrial applications. So this video again is about physical methods of control, and we break it down into 3 categories: temperature, which it can be hot or cold, and then if it's hot it can have moist heat, so we've added water, or dry heat. For radiation and those ionizing radiations, we can look at either non-ionizing or ionizing, and then we have filtration. So let's start first with our temperatures. Again, temperature, we can either use cold or we can use a heated temperature. Now, the difference is, and we typically want to use elevated or hot temperatures because that's going to allow us to kill the microbes, whereas lower temperatures just inhibit their growth. So as far as with those lower cold treatments, think about it. We put our food in our refrigerator, but it's still, at times, you will find that you get the food has gone bad, has spoiled. Why? Because refrigeration just slows down microbial growth. It reduces its metabolic rates, but it doesn't do anything to actually kill the microbes. Very similarly, that happens with freezing, where it's going to literally, by putting something in the freezer, you're going to halt the microbial growth because of the fact that it's going to inhibit chemical reactions, but it doesn't kill them. So for us, we're mainly going to talk about the heat treatment because, again, they're going to be able to kill microbes using heat treatment. A term to know is thermal death time, and what this means is it's the amount of time that you can apply that heat process, for how long, for what temperature, in order to get to a sterilization. That doesn't always mean that it is a method that is a viable method to use, but that is what the thermal death time is the time required to kill all, so to sterilize microbes at a specific temperature for each process. Now, again, we talked about the fact that there is more than one method for heat treatments. We have both the dry heat and the moist heat. So let's start here by talking about dry heat. So dry heat involves the use of hot air or an open flame. It's less effective than moist heat at killing microbes because it generally just takes a lot higher temperature and a longer period of time. Dry heat can be used on inanimate objects and including oils. And the main examples are going to be where we use incineration and hot air ovens. So when you're talking about a dry heat in an oven state, you're usually going to get it to 150 to 180 degrees Celsius for several hours. Whereas if you're using flaming or incineration like we do in micro labs when we use the flame or an incinerator to sterilize our inoculation loops and other equipment, then it's going to have to get to extremely high temperatures. So when we're just flaming, it needs to be 1,870 degrees Celsius. That's extremely high. Whereas if you're using like a furnace, 800 degrees Celsius. So again, that high temperature can make this a not practical process, especially for lab settings. Now, moist heat again is going to involve the use of steam or hot water, and again, it's more effective than dry heat because we can have reasonable temperatures. So when you're talking about moist heat, this is going to be autoclaving, pasteurization, and even boiling water. Now, moist heat, when you talk about boiling water, is not a sterilization process, generally speaking. At home, people don't get the water hot enough or do it long enough for it to be sterilization. So at home, it's generally going to be a disinfectant level. But autoclaving by far in labs all over is the most common sterilization process used. Now, one of the things that you must know is how do we reach the level of sterilization using an autoclave? An autoclave is like a big pressure cooker. So we have steam, it's got water in it and steam and a high level. So it has to reach 121 degrees Celsius at 20 pounds per square inch of pressure there, and then you have to do it at a minimum of 15 minutes, and generally the rule is 15 to 20 minutes, and then that will reach a sterilization level. You can use autoclaving and moist heating on inanimate objects such as glassware and liquids. However, because you're using water like steam and moisture, obviously it can't be used for those kinds of products for which water can damage, unless of course the whole purpose, like with an autoclave many times, is used to, it doesn't matter what the end product. So if you put plastics in there and they melt and become misshapen, it doesn't matter because you're using the autoclave to sterilize, to throw something out. So for radiation, let's talk just a little bit about radiation here. It's another form of control. And when we talk about radiation, radiation is that energy that gets emitted from radioactive components, so atomic sources, and that is going to be, they produce radiation, which is a wavelength. And then that energy behind of the wavelength is going to help us to categorize it. Is it ionizing radiation or is it non-ionizing radiation? So when we talk about ionizing radiation is a very high energy radiation. It's going to go in, its energy wavelength allows it to penetrate through surfaces. So this is going to be like gamma rays, X-rays, and cathodes. So think about it. Probably the one that you're most familiar with is an X-ray. It's ionizing radiation because it's allowed to go through the skin and the various tissues down to us seeing bone. So it's able to penetrate that surface. Now, ionizing radiation can kill microbes, can kill other tissue as well because it damages DNA and other cellular components. But it is something that can be used for control. Non-ionizing radiation is a lower energy radiation, and it can still do damage, but it's going to do damage to the DNA and RNA by preventing it from replicating. However, one thing about that shorter wavelength is that non-ionizing radiation does not penetrate the surface. So it's great for cleaning things on a surface like a UV light, but it can't penetrate through. So For non-ionizing radiation, UV radiation is used for like disinfecting water treatments and surface sterilization in various industries. So again, the big takeaway here is that ionizing radiation, because it's able to penetrate through the surface and get all the way, is able to destroy, it's using destructive ions which can take out cellular components, whereas the non-ionizing radiation, because it's not able to go through the surface, it's just able to destroy DNA within the cells and prevent replication. Filtration. In the filtration processes, one thing to recognize about filtration is it's just like what it sounds. You're using a filter. So this is actually a mechanical method. It's not a process that's actually going to kill or destroy the microbe. It's a physical process that's going to prevent microbes from moving through a filter based upon a specific pore size. So we're able to remove spores from the liquid and for gases. So filtration, it's used for liquid, it's used for gases, and based upon its pore size will help us to determine that level of control. And so we use filters a lot of times for pharmaceuticals and in the beverage industry and food industries. Now, other methods that you will hear about are things such as the high pressure. And high pressure is when it's literally kind of like a pressure cooker, if you were, and it's using those high pressure to inactivate microorganisms and or they're like enzymes, and it's used quite frequently in the food industry. Osmolarity is another way that we can prevent microbial growth. You may recall in the previous videos when we're talking about osmolarity and getting the right salt concentration in the is it hypertonic, hypotonic, and you want your microbes in order to grow, they have to have the right salt or sugar concentrations, etc. Well, we can use that to our advantage if we're trying to control or kill microbes as well. So we can use high levels of salts and sugars, and this is often used in food products to inhibit microbes from growing. Why? Because we create that situation in which we're pulling the water out of the cells and they're drying it out. Okay. Then we have mechanical processes, and in this one we use like ultrasonification. Okay, and this is where you use a high frequency sound wave, and that sound wave produces pressures, that variation, and it can cause disruption of those structural components within cell walls and membranes, and then that can ultimately kill the cells or help them to become inactivated. Now, that process is often used for cleaning, and it's in medical and laboratory facilities. So those are our physical methods of control. Again, you have to be able to pick the right one depending on what the situation is. What is the component that you're using it on? Is it skin, for instance? Then you're going to have to use an antiseptic. Is it a liquid? Is it paper products? You might not be able to use an autoclave, for instance. If it's metal, then you might be able to use an autoclave, or you can put it in the dry oven. So again, how and why we use things are going to be dependent on that application and the level of control we need. So don't forget to look for the next video on chemical control methods.